to my mom with the chicken she raised.
Yeah.
Well, we hate to interrupt these fun conversations we have, but it's time. We are back, ladies and gentlemen. Another episode of the SBAU Astro Hour. My name's Ronnie Heron, ex-radio guy, now Zoom host, and this will be Astro Hour number 275 for June 1st through the 7th, as we are now in our 6th year online, ladies and gentlemen, kicking around this cutting-edge cosmology. On behalf of our South Coast Astrophysics and Telescope Club, longtime group, the SB Astronomical Unit, all of us on screen love this stuff, and we're longtime members of the club, which meets most months on the first Friday night at the beautiful Santa Barbara Museum of Natural History, then assemble outside in the dark on the second Saturdays for our well-attended star parties. This month we're a week later and we're doing our yearly potluck. So no meeting, but we got 2 events in a row next weekend, the weekend after this. Also everywhere with our scopes, man, hotels, state parks, schools, nobody does outreach like our club. Website is sbau.org. Weekly Astro Hour is on YouTube, and this week's hot topics. Well, the middle of the night, our second full moon of the month. That makes it a blue one. Got the next generation of Mars exploration robots in design stage, and we got lots of maps and diagrams and photos to show you this week. NASA, back to the moon here, suspecting that lava tubes up there may have left behind a network of subsurface tunnels. Or is a TV series in the making. Knowing where they're training those, where they're training those future moon micro rovers? There's a West Desert sinkhole up in Utah. Looks like a crater. And let's see, globally clusters, some massive, unusually hot, very luminous blue stars out there. Shouldn't be there, ladies and gentlemen. Get this, a star's lifetime, can't read my own writing, is and its color are inversely related. And I guess you saw some of those incredible meteors that one of them back on the East Coast not only plunged into the bay off Massachusetts, but provided, man, a big flash and a huge sonic boom. Let's meet the guys, shall we? Ladies and gentlemen, man in charge, our beloved Jerry Wilson, the president, and he becomes Professor Jerry every week. How
Good
are you,
morning, everybody? And good morning,
Hi, guys.
Joyce and Riley and Calvin.
And Pat Forgy is probably going to duck her head in sometimes.
She's
got
not here today. She's out shopping.
Did you get the upstairs refloored or whatever you were doing a week ago? Is that done?
No, it'll be done, we're guessing, by late July.
Oh,
We're
okay. They're
getting
not in the house right
we're
now.
getting our master bathroom remodeled, and we're finishing details of remodeling our kitchen.
Okay. Let's meet the outreach coordinator for the club, Chuck McPartland, with his favorite cat. Got several. Kill. And Pat is his wife. He's married to a Pat, merchandise manager and our incredible treasurer. And Tom Whittemore joined us. He's married to Maureen.
Morning. Morning.
Edits our newsletter for the club, and doggone taught so many years in his own, I guess, Westmont. You had a whole lab, didn't you? You weren't just at a...
Well, I taught labs out there. That was my favorite thing, besides the observatory, was
Okay. Well,
teaching the general physics labs and also the electronic circuits.
how many years have you been editing our paper, our online
Over
newsletter?
20. Chuck will know. I think
Well,
I
okay.
started in 04, if I
All
remember,
right.
the beginning of 04, maybe.
Bless your heart. Hey, here's Tim Crawford, resident lens expert, telescope guy, married to Karen, and going to open our December in-house members only speeches. What are you going to talk about? Do you know yet? You're working on it.
I ran how I was going to begin by my wife, and she frowned and said "Ugga," and so so I'm currently scrapped everything, and I'll start again.
You talk about guitars?
No, I'm just gonna talk about the little 8-inch Dob that I built.
Yeah, it's nice.
And I'm gonna try and wind into that at your mirror making classes, Tom.
Maybe. Oh, that's neat.
And then actually, just show them off, and maybe a couple of slides on some of the way we test them, and I'm going to try and make an argument for why I think it's a really good scope to get for a person that's interested in starting out.
Yeah, Tim, if you're interested, I have movies of Dimitri working on his mirror, if you could use stuff like that.
Well, I don't know.
You got a lot of stuff.
Yeah, I've got
Okay.
enough, way more than I need, probably.
Okay, okay.
Well, Tim's going to open for the guys pictured above him, who I guess caught a occulting moon around an asteroid. Chuck McPartland will cap up.
Yeah, I don't want to follow that guy.
No, you're opening. You're opening for Chuck. It's high time. It's been years since we've had him on.
He's
We
a
do
hard act
silly-
to follow.
Okay, we do silly cartoons every week to get us in a good silly mood. Not that we need them, but it's always fun. I don't know how President Jerry comes up with these, but he forwards at least half a dozen to us. I counted 7 this week, so let's go to the screen
We
and
got a Bizarro too.
have some bizarro stuff. I kind of write down my comments about them, and then I can't find them as he calls them up, but that's all right. I'll
Was
have
he
one
the-
guy read-
Yesterday's paper would
Yeah.
be great for trying to find all the little gizmos that he sticks in.
Yeah.
Yeah.
This one's, there's not too many, I don't think, but
Are you having trouble calling it up, Mr. Prez?
No,
Oh, here we
I
go.
was daydreaming. Let's
We haven't
see.
had a good
Go
Larson
here.
cartoon in a long time. Far Side. I guess you ate all those up over the years, didn't we?
Yeah. So while Jerry's doing that, have you guys been enjoying Jupiter and Venus coming together? It's really been spectacular.
Well, certainly enjoyed it too on the 13th of this month. Okay, Mr. President, looks like we're about to become a globe on a desk.
That's
Can
a
you
good
read
one.
it? Can you read it? Right, it's a little washed out for me.
Oh, it says, Mr. President, we have a theory regarding that alien ship approaching Earth.
you know, the first time I read that, Jerry, I thought it said the Ori.
Yeah, yeah.
So what is that called? That's never mind. It's a rack.
Yeah, it's a support.
Okay, what's happening here, Chuck?
You
Aliens.
got me.
Aliens
Yeah, I don't know what this one's about.
There
Okay,
goes the
so-
neighborhood.
So apparently there's some guy that had his picture taken in front of some kind of silly alien display. And supposedly he's the spokesman for the aliens, and he's saying, we're here to steal every third Tupperware lid, every other new sock, not impede us in any way, or we'll make another straight line in the Nazca Desert and 2 crop circles.
Very good.
Now we know where the missing wallet went to. Okay, you're going to need to explain somebody, Jerry, IT, what does that mean? I don't understand that one.
Interface technology security in the 1990s
It's a index file, right?
of 3-inch discs,
Right.
diskettes.
Floppy
Okay.
disks.
And this was what you had on your desk and you locked it.
Oh,
Yeah.
You know,
Been a long time, huh?
we were doing work down in Northridge with classified stuff, but we had floppy disks or disks like this, little 3.5-inch disks that we had to bring in and out. They didn't have classified information on them, but there was a security search as we went in and out.
Hmm.
And we had a container like this that we put them in. And whenever we brought that container, they spent minutes, going through looking at every single disk that was in there. Not that they put it in a computer, they were just reading the labels.
Yeah.
And we found out that if we just tossed them into our briefcases, they would take a brief look at the briefcase and just let us through security. So we stopped using the carrier.
Your,
wow.
your security was different than my security. At Hughes, if you worked in a skiff, a
It's
Secure
secure.
facility.
classified facility or room, you
Mhm.
had to, you were not, anything that you took in did not come out. So if you took your laptop in, you gave it away.
Wow.
Oh, wow.
So you had to remember what you were doing. So I'd spend the last few minutes of my time in there memorizing a few key things I was working on. Then I'd write them down real quick when I got out.
Wow.
Well, these aren't floppy disks we're looking at, right? They're
Yes,
just
they
cards.
are.
They're
Yeah,
little
yeah.
floppy.
Yeah.
They're not the
Oh,
big
okay.
floppy. They're
Not the big floppies. Those are more like 5-inch, right?
Yeah.
Mhm.
All
You know,
right, how
Jerry-
about Tom Whittemore, you want to explain this one? The doctor is talking to a patient, obviously, and he says what?
Yeah, you'd pay out of pocket for surgery, but your plan covers using Photoshop to delete the growth from your x-rays.
Okay, I'm not sure I understand that totally.
Saying that the insurance won't cover the surgery.
Yeah.
But they'll cover the cosmetic adjustment of your x-ray pictures.
Right, yeah.
Yeah.
Oh, I see. Okay,
There's
gotcha.
there's the little spaceman.
Yeah.
All right.
There's the dynamite. There's O2.
There's the eyeball next to the.
Oh, that's right. The eyeball.
So O2 is one of the things?
Yeah, O2 and K2.
Okay.
And then there's the little crown.
And this
Oh, so there's a
bizarro
crown.
person,
Okay.
I
this
don't
guy,
see the. Oh yeah, the crown is here.
he's still producing stuff, this bizarro guy. Huh?
Yeah.
Wow. Okay. Who wants to try this one?
That's Tim. It's got Tim all over it.
Tim, read that to us. What's going on?
I didn't
Two
see
people.
this one. How much trouble do you think we'll be in if they find out we use neutrino project grant money? Oh, yes, I did.
Yeah.
And money to throw a huge pool party instead. We could argue that we did build a neutrino detector. There's a lot of water here. Solar neutrino will probably interact with it at some point. Wait, actually, we've got some photomultiplier tubes. This is how the neutrino detector was invented. Now, these things are really normally just buried way down in the earth somewhere.
Yeah.
Yes.
And they use water in this case with
Very
neutrinos
pure water or some other fluid.
because they're using liquid neon or xenon for the trying to find WIMPs, the dark matter. I
Right.
think it's liquid. Yeah. Okay. Chuck, guide us through the toilet.
Well, okay. I guess this is some future space facility, and they're looking in at the bathroom, and the toilet paper has unrolled from the roll and is floating off. And you can see a lack of privacy on board is the least of our troubles.
Okay, Jerry. Three
Here's a
boxes.
group of people that are always taking pictures when they go on vacation. And one guy rebels against that. And he said, put your phones away and enjoy the moment. And the moment they see is not going to have any tomorrow.
Okay, that's our bad one, huh? Coming in.
That one I missed.
They estimate the one that just crashed off Massachusetts over the weekend that made a sonic boom was about a yard across, about a meter. We can
Yeah.
take a rock that size.
And it
100
was the equivalent of 300 tons of TNT going off in the atmosphere.
Yeah,
So
it would.
Chuck, there's no chance that we would have felt, rattling windows on our house at that time?
No, not from
Okay,
Massachusetts.
not that far away.
Yeah.
Okay.
Somebody's going to try to get it. It's 100 feet down in the bay, supposedly.
Oh,
This
In
is
little
a really
pieces.
pretty picture.
This is gorgeous.
Yeah.
What
Yes,
is that?
this one is celebration of yesterday, because yesterday morning we had the last full moon of 2
Mhm.
in May, so that qualifies this as a blue moon.
Yeah, the moon's been
Why it's
just
so dark
beautiful.
here.
They've been just
I-
so beautiful coming up and, Scorpius. And I've been watching them Friday, Saturday, and Sunday evenings.
Yeah.
It's really pretty.
So this was about 1 p.m. in the morning yesterday. Now,
Okay.
the times I listed in the talking points are correct, but I forgot to change the letters EDT to PDT. So they're actually PDT times, but it doesn't matter. That was yesterday.
Mhm.
What did I miss the building? Is that local?
No.
So this is the Basilica Superga in Toronto, Italy,
Oh,
in
Wow.
August 2013. And
I
it was a blue moon.
This remind Chuck, this next Friday, is it last quarter or near?
Yeah.
Okay.
so anytime we get 2 full moons in a month, that's a blue moon.
That's the more recent definition of it. There was another definition earlier that I've forgotten.
Chuck knows it.
The earlier definition was third full moon in a season that has 4 full moons.
Oh my
Okay.
God.
And that was much rarer.
Yeah.
But sometimes we give them another name, don't we? What's the name? Like harvest in the fall and stuff like that.
Oh, those are all just, yeah.
Hmm.
And those
We
are
don't
for
have one.
full moons that are by themselves that month.
Okay.
The third full moon in
In a season that has 4 full moons.
Yeah.
Okay.
So in a 3-month period.
Yeah. And I was just going to mention again that, for people who like to look with their eyes, uh, towards the west, that I've just been watching Venus and Jupiter get closer and closer and closer. And on the 9th, they're going to be pretty close to one another. And you'll also be able to see Mercury down low, turns out.
And actually that's you can see it now if you got a really good western horizon.
Yeah, which we do. And I saw it.
You do,
Okay,
not
yeah.
me.
Well, this is Mars that we're looking at, isn't
Yeah,
it?
that's Mars. That's a morning thing now.
Yeah,
Wow.
but this was taken a while ago.
Hmm.
This was Mars in 2022. Taken by the Hope spacecraft.
And that's the volcanic area. That looks like Tharsis Plateau there.
Yes.
Wow.
Yes, there's Olympus Mons, and there's a chain of 3 volcanoes across here. And it's a little clearer in this picture.
Hmm. Wow.
Exaggerated surface.
Yes,
Believe,
exaggerated
yeah.
surface.
in
but
the
you can
middle
see
of the 3 is the one we're going to be studying.
Yes, this is the one that we're going to see pictures of coming up close in. In this region out here is where there appears to be lava tubes.
Hmm.
And you might expect that's in a region where there's volcanoes. There's also a probe. This is a little sidebar. There's also a probe I read about that's going to be a rough terrain traveler to go out through this. What do they call that? The Grand Canyon.
Marineris?
Yeah,
Yeah.
Valles Marineris.
Vale of Marineris. Yeah.
Mhm.
So now what we're going to see, the next part of this talk or discussion
Mhm.
is concept phase, not contracts let, but concept phase of trying to figure out how to explore these lava tubes and where they are. So this is a map of that region.
Mhm.
It's called the quadrangle map, meaning there's 4 top 4 things, but it's into quadrangles. The third volcano is down here to the bottom left, but this one is Pavonis Mons right here.
Yeah, that's interesting. Do you know what that means?
No.
No.
The mountain of the peacock.
Hmm.
Yeah. Pavonis is the possessive for Pavo in
Huh.
Latin.
I
Pavonis.
wonder how it earned that name.
I don't see a peacock in it.
No, you must be left-brained then.
Yeah, I definitely am.
Yeah, okay.
Well, your first picture was titled at the top, "The Volcanoes Side of Mars." Is it only got volcanoes on one side?
Pretty
This is
much.
where a bunch are concentrated.
Oh,
Yeah.
Wow.
well,
The dramatic ones are on this side.
3 volcano side. I got you right.
Phew.
And those among those 3, not even Olympus Mons. That's the big
Yeah, that's that
glitch
guy.
over to the left. Well, I'll be damned.
Yeah. There's one here too, and there's one here. And this, I believe, is a crater. But you see, it's not heavily cratered
Mhm.
by the moon, like the moon is, indicating that this is it has active geology of some form.
Yeah.
And you see that crisscross chaotic, it's called chaotic terrain there at the head of Valles Marineris. What they think is there was a lot of ice under the soil there. And when these volcanoes became active, that melted, the ground collapsed under it, and then the water came out through Valles Marineris and did some of the erosion. And you can see where it flowed out on the right side.
Thank you. You know, I was really wondering if there was a relation here between the volcanoes and the large Grand Canyon there. It's supposed to be bigger than the Grand Canyon, right?
Oh,
It
much
is.
larger, yeah.
Yeah. Yeah.
But Olympus is 3 times as high as Everest, isn't it?
Yeah.
Mhm.
Well, this one that Jerry's looking at, I think it is as high.
You think what?
I think that Pavonis Mons is actually a little bit higher than Everest.
I don't know. I
think
think
it's about-
Olympus Mons is supposed to be the biggest.
Yeah.
Yeah, but this
But it's
one
3
this
times
one's
Mount
over
Everest.
just over 30,000 feet.
For Pavonis.
Yeah. As far as this goes right here, this scale.
Yeah.
Yeah, that's saying, yeah, let's say 15,000 meters. Yeah.
Wow.
Yeah, so this is a geology map of this is a representation of that side of Mars. And this is a colorized elevation map for a geodesic map for the Pavonis. This one here, the little thing with the little Gatorade in the bottom of it, that is almost zero elevation.
Gatorade. They should call it Gatorade Lake.
Gatorade Lake, yeah.
Well,
I don't know the official name of that.
And it's hard to tell your Gatorade reference because this is blown out. The color's blown out, so it just looks white and yellow
Yeah.
instead of the green.
Yes, they're on the screen again. It's not faithfully reproduced.
Yeah.
But gentlemen, our May 3rd speaker from JPL, Dr. Freeman, detailed Curiosity going up a mountain, but it wasn't one of Mars's extinct volcanoes, was it?
No.
And there's no plans to climb any of these that we're looking at by NASA.
We are climbing Mount Sharp in Gale Crater, I think it is.
Well, that's the one Ronnie just mentioned, but yeah,
Oh, okay.
that's not volcanic.
Yeah, it's not. Volcanoes, I don't know of any plans in it. These are conceptual plans for probing the lava tubes, because the lava tubes will offer safe shelter on Mars, relatively safe, from radiation and meteor impacts. Now, this is a very confusing picture to me. It makes it look like these are bulges because of the way my brain always wants to see light from the upper left.
Me too, Jerry.
But this one is not that way. You see, this crater down here is a depression, and it is illuminated on the left side because the light's coming in this way. So that means the light's coming in this way and illuminating the opposite side. So it's high here and low here. And these are lava tubes that have collapsed, or not completely to open the lava tube, but it's not supporting the ground above it. And so this is a place to look for lava tubes.
Did I misread your talking points? Is the lava tubes that I mentioned, I thought they were on the moon.
We're looking at both Mars and Moon.
Oh, they both have lava tubes. Okay.
Yeah, you notice I put down there dual use.
Mhm.
That's a Department of Defense and NASA key phrase for what was going on to save money in the 90s after the Soviet Union collapsed and the defense budget dropped by about 50%. And so they wanted us to reuse everything that we'd all built for something. They wanted to find a second use for it so they didn't have to redevelop something that's very similar for a different application. So the catchphrase that way was dual use. And the best example of that I saw of dual use successfully applied was the Messenger spacecraft, where it was basically put together out of remaining parts of other spacecrafts that were scrounged together.
Do you mean Messenger or you mean the New Horizons?
I mean the one that went to Pluto.
That's New Horizons.
New Horizons, excuse
Yeah,
me. Thank you.
Messenger
Yes.
was Mercury, right?
Yes, you're right.
And also dual use when you're talking about export technology means it's something that has both civilian and military uses, so it has export restrictions on it.
Yes.
But I'm
So,
imagining,
yeah, go ahead.
I'm imagining that whether it's Mars or the moon, NASA tries to stay as flat as possible on landing sites, because if one of those suckers, any of them, tipped over because they're landing on a moon,
They haven't dealt with that yet. They are looking for, you'll recall, the first one, Apollo 11. They went to, and it was a boulder field, so they couldn't land there, even though it was flat with boulders on it. So the guy flew around until he had like 30 seconds worth of fuel left, and then he touched down. So
they're going to have to invent a rover that rights itself.
this
Okay.
was, yeah, the rover at that time, the lander was not capable of righting itself.
Well,
Wow.
if you look at the pictures from the Viking landers from 50 years ago, one of them landed with one of its legs on a boulder. Luckily, not a really high boulder, but the horizon is tilted in the pictures.
Yeah, yeah.
And with the opportunity, Spirit and Opportunity on Mars, those rovers, they landed in the big soccer balls that bounced and rolled. So that was kind of a way to try to get them to end up in a flat area.
Or a hollow.
Oh, yeah, inside a crater. Yeah.
Yeah.
And on Mars, Ron, on Mars, they'd be red rovers, right?
Yeah.
What was in those balloons that landed on Mars? Air?
Rovers. Oh, I'm not sure what they inflated them with. Could have been
Okay.
nitrogen, carbon dioxide, who knows?
Yeah, I'm guessing it was nitrogen.
Yeah.
But
Wow.
this is a picture of the same region as this, but
Hmm.
this is straight on from a spacecraft.
Mm.
And you can see the pattern of big collapsed areas, and then lava tubes down here.
Wow.
That have fallen through in some places.
Lava
There's a
tubes
lava
look
tube
like-
under it, but it's partially caved in. And then what I learned is that when it's caved in enough that you can see down inside, they're called skylights.
Ah,
Skylight.
And that's what they're looking for.
Hmm.
Now, this is a skylight.
Be damned.
This skylight is 35 meters wide, surrounded by a collapsed pit on Pavonis Mons. So this is on that volcano. And you can see part of the floor down here is illuminated. So you can guess the depth from this lip to the lip of its shadow by that distance and the angle you were looking down at. So they know you can figure out the distance. When you fly over these things with an infrared camera, you can also take a picture. The infrared radiation in the bands you're looking at will show you the surface temperature. And the average surface temperature they're measuring from the bottoms of these skylights is minus 30 degrees Kelvin. So it's not as severe as being out on the surface at night, or as severe. Well, it never really gets hot on Mars. So, but that's something you can plan for. We had a type of detectors that we made that were called room temperature detectors. They did not require cooling in order to operate. And so we were working on a project one time, and they said, these are room temperature operating things, and we're going to use them on Mars. And I said, well, just what exactly is the room temperature on Mars? And so no one knew that yet, so we had to figure it out.
Did you say minus 30 degrees Kelvin or 30
Yeah.
degrees?
No,
Minus.
minus 30 degrees Kelvin would be below absolute zero.
Oh,
Oh,
is that below
So
absolute? So it'd
30
be like
degrees, minus 30 centigrade.
how
Oh,
much,
minus
how
30
much is that
centigrade.
Fahrenheit?
Okay.
Yes,
Yeah.
yes.
Now, what's the one temperature where Fahrenheit and centigrade have the same numerical value?
Something
Anyone
like
recall
80.
that? It's minus 40 minus 40
Minus
centigrade.
40, that's right. Yeah.
Is that right?
Mhm.
Well, do these things also protect from radiation of the sun?
Yes, it's more than 3 feet of regolith on Mars will protect you from radiation.
Huh. And so there's tunnels
So
on
this is what's
Mars
going to
and
have to do for a magnetic shield.
Now,
Wow.
would an infrared camera, if you were sensitive enough, you could probably map some of the tunnel structure below from temperature changes, maybe?
You're tickling a future topic here,
Okay.
but I don't know about measuring the temperature, but there's a process for some of the rovers that are planned to use temperature differences to cause wind.
Huh.
We'll get to that.
Wow.
Now, this is a much larger one. There's collapse and there's debris on the floor from the collapse. And this is a 180 meter wide lava tube on this volcano's southeast flank. So this is a major structure that has collapsed. And the edge of this the edge of this looks like the one we looked at looks like an antlion trap.
Yeah.
Oh, you
Yeah.
go, whoa, 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 and then you fall in.
Yeah.
That would be a little challenging, but doable. This one is something more you can let down a wheeled vehicle down the side with a cable on it to hold it, and you could get down that way. This is a picture of a lava tube on Earth, obviously. So, and this is what it looks like. It's hardened lava, so it's quite structurally strong, except where it's collapsed. And it might collapse because it got hit by a meteor, or it might collapse just because the structure failed.
The
Yeah.
lava used to flow through that sucker.
All right. And if you're interested in seeing this, it's in Northern California. I don't know if this one is, but it's near Bernie Falls. And I've gone through those tubes up there.
This one, it says it's on the Canary Islands.
Okay.
So these tubes are usually around a volcano, taking the lava out of the hole of the earth and depositing somewhere else that doesn't harden right there.
The lava got out of the tube before it hardened.
Yeah.
I'll be damned.
Now these are conceptual design. They're called pill bug inspired robots. And these are designed to move around in those tunnels and get down into the tunnels and crawl around once inside. So they would, this guy, well, this is it, and this is it unfolded. This is it unfolded. This is it folded up. These are actual insects. Insects.
Yeah.
When I first moved here and had children, my 1-year-old firstborn, as soon as he got crawling, would go and I'd pick him up and he'd have pill bug shells on his lips. So he'd been eating them. So I guess they're not harmful to eat.
Yeah. Did you call them roly-polies too, Jerry?
Yeah. Or
Yeah.
sound
We call
bugs.
in the Midwest, we call them roly-polies.
Yes,
Yeah.
I've heard pill bugs, roly-polies. We called them sow bugs.
Okay.
They become a ball. They turn right into a little ball, right?
Mhm.
Yeah. You can open them up, some of them into centipede-like structures, which this is, but tethering it and then lowering it down in would be what the round phase is. So these are in a conceptual phase. When they want to, way before contracts are let out, they do feasibility studies and conceptual design levels. And that's what these are at. I would say from some of these pictures that they've built working models of some of them. Some of them look like computer construction.
Mhm.
But
That doesn't look like a good idea to have all those exposed wires once it's unfolded, because those could catch on stuff.
you mean like in here, exposed
Yeah.
wires?
Yeah, then you'd have to debug it.
Yeah.
All right, you guys are cards and need to be dealt with here.
You know what's missing is a trilobite. Remember those?
Mhm.
Well, trilobites didn't have, I don't know what trilobites have and don't.
I mean, they might make a good rover the way they were designed.
But
Yeah,
they can't roll up.
That's
Right.
true. You're right.
so they want to use these in conjunction with traditional rovers, but tethering the robot for lava tube entrance. So this one here has a cable, and this is a picture of that one we saw. Cable that lowers this thing down, but this can't get any closer than the top of that rim.
Yeah.
And this is the thing all rolled up. Now this is, and same idea here, tether for communication and robot transfer. So they can also pull it back up and go somewhere else.
And,
Wow.
they'll lower it down there, and then all of a sudden they'll get a bite from something and it'll pull on them. And
Well, who's making these things? Your Boeings and McDonnell Douglas and whatever's available.
The roly-poly ones are from New Mexico Technology. It's a startup company. This picture is also from New Mexico Technology.
But we've all
This one-
seen some of those Japanese humanoid style robots that can outrun humans recently on screen, and they could
Those are
send
I don't
tiny.
think they're working on them for speed.
well,
But what they're going to do is they're going to release, you see these things here that look like dandelion seeds? And
on the
there,
right, where?
that's exactly what they are. They're probes. And you see this swirling pattern up here? These robots disperse the dandelion-inspired micro-flying sensors. So this depends on there being a wind in the cave. And that means that the temperature here is different than the temperature farther in. And as the day progresses, winds will blow one way or the other. To my knowledge,
Interesting.
there's no evidence that there's wind in these things. So they're in these tubes. So they're hypothesizing. And they said the motion planning would be based on sensor feedback. Droppable mesh node wirelessly power nearby sensors. So
Going
this
to depend on the opening
Wi-Fi.
too.
What's that?
It's going to depend on the size of the opening.
It's going to depend on a lot of things.
Yeah.
Mostly luck.
Yeah.
But they're all equipped with little radio transmitters and receivers.
Yes. These are
Send it
like
up to-
the fluffy things that Phil Lubin is planning on sending to Alpha Centauri. But he's using phase-locked laser beams to shoot them up to them close to a significant fraction of the speed of light. Here, they're just going to blow around in a light wind.
Jerry, I know that the idea is to be able to survive in these lava tubes, but the mean temperature that they're dealing with here is going to be different than the moon, or?
Yes, it is. We'll get to that.
Okay.
So this is actually a general thing, shows that this was sketched for the moon, but it's the same idea as on Mars. So it's a rover with a crane that links down, and then you send these little mobile rover repeater things so that they can park it certain ways, and you can get a network. They can bucket brigade the signal down to their data to deeper in the cave. So pretty straightforward idea. This was developed for the moon, and it transitions us to the moon. Now this is a lunar lava tube. Looks just like the Mars lava tube, but there's less dust up here to create an antlion trap. But the temperature measured for the bottoms of these things on average is about 70 degrees centigrade. So they're warmer, and they're at a little. That's a hot temperature, though. I mean,
That's really hot.
yeah. So, but it's not as bad as being out here, and we certainly have been out here. So our life support systems will work in there.
I wonder if the further in you get, the more the temperature might drop.
I think it might go down further because it's less bathed. You know, in caves on the Earth, you can get caves in tropical regions like Saudi Arabia, and the inside the cave is a constant temperature all year round, pretty much, because the rock that surrounds it holds the heat and then releases it steadily. So it doesn't get cold and it doesn't get really hot because it's shaded from the.
Yeah.
And the plan would be to wall off sections of this and then have doors so you could heat individual cells that you build in there.
Yeah. And if you get lucky with the composition of the sides, you can wall off different sections and pressurize it.
Are you saying that when the Apollo astronauts were on the sunshiny lit moon surface, it was hot?
It was
Yeah.
hot during the day and cold at night.
And Ronnie, it was not only that, but the side, if they were standing sideways to the sun, the side of their body that was in the sunlight would be at like plus 200, and the side of their body that was in shade would be at like minus 100.
Yes.
And so they
Wow.
had to have water circulated in the suits to even out the temperature.
Yeah.
But I'm imagining perhaps there's two plans to colonize Moon. One is to bring their own buildings, and the other is to use these holes in the surface.
You're ahead of where planning is.
Oh,
Those
okay.
are at the concept level. They're notional. we'd like to do this. We sort of are going to do this, but detailed plans have not been made for that. And I think, as you pointed, I think it was you that pointed it out earlier, the biggest problem they're going to face is trying to land one of Elon Musk's starships on the surface, because I think they're going to need a paved, level concrete pad to land on.
Yeah.
And there's nothing like that on the moon. So I think they got a big landmine waiting for them.
Well, get Granite Construction to do it.
Yeah.
Yeah. So I'm sure they would willing to do that.
There was one guy in our club that was talking to me once, and he, he didn't know a lot of astronomy or physics or anything. He said, I don't know what all these problems are with going to the moon. I mean, just send up a D4 Caterpillar dozer up there and build whatever you want.
Yeah.
Yeah.
Well,
the other thing
I
is that
guess
I'm wondering if they could actually drop, use gravity, just drop stuff onto the surface. Crushed granite makes a nice little pad.
Okay. I read plans, loose plans. If you take the regolith and you have a big Fresnel lens, the sun will melt the regolith into a concrete-like structure.
Nice. That's nice.
So there's another thing that if you've been keeping up with speculation lately, Elon Musk is planning on putting one of these data centers in orbit in space. And they require so much cooling. Someone wrote in and said, where are you going to get the water to cool it? Well, if you're in space, one half of you, as Chuck pointed out, is facing the 4 Kelvin background of deep space. There's no problem getting rid of heat on that side.
Wow.
These are 3 lava tubes on the moon. That one that we just looked at was in Mare Tranquillitatis. The skylight spans 65 meters. The floor is 120 feet below the surface, or 100, feet below, And Arizona State University has made a study of these kind of tubes on the moon. Whoops.
You can tell these are Americans when they give you one measurement in meters and the other one in feet.
Yes. On the left is the Marius Hills pit, 210 by 300 feet, with a rubble-strewn flow. This was the same one we saw a second ago. Oh no, it's a different one.
These are all the same. These are all pictures of the same one, just at different illumination angles.
Yes. Oh no, this is not. This is no,
different. All 3 of these pictures are the same one. If you look at the crater pattern.
Yes, you're right.
Yeah.
Okay. So this is the Marius Hills pit, 210 by 300 feet. And this is a plan, not built yet, that shows an artist illustration of a micro rover survey for a lunar pit. It will be let down on a cable. And when it comes to the edge where it's over, it will sink down. On this thing, there's a company in Germany that is making a rover like this with wheels that are wobbly on paper. They're snake. They're not a single section of a cylinder. They wobble like this because those kind of wheels will swim through deep sand like lizards can run through deep sand. And so those kind of things, but it looks very similar to this, but those kind are made for Mars where they have deep sand that bogs our things down. But
looks like it looks, Jerry, like there's a slot on the, like a little dovetail slot on the sides to reposition the solar panels.
I don't see what you're saying.
Well, on the side of the where the solar panel is, that bottom plate, it looks like there might be little dovetail channels there, so that a little motor can lower or raise the panel to get.
Oh, you mean this can change its angle?
Yeah.
That's certainly a possibility. I don't know if their conceptual sketch has gotten that far yet.
Well, is this an artist rendering or is this
no, this is an artist rendering.
But you're leading up to the big sinkhole in Utah, aren't you, soon?
Yeah, this is the sinkhole.
Oh, there it is. Okay.
in Utah served as a training ground for micro rovers designed to explore lunar pits. So this is a rover, a straightforward platform, and it's going to be let down. See something up here. It's going to be lower itself down into the sinkhole.
Wow.
It's really washed out, so it's hard to see some of those details on there.
Oh, okay. Sorry. So this is the miniaturization of a 6.6 pound moon weight for the rover we just saw drawn at the edge of a lunar crater. So they're small, 30 inches. It's about 3 feet by 3 feet. And a 20-inch diameter standard. This is the kind of wheel that we're using now on the rovers. And you see these are structures different. This is for any angle of attack. Here, these are for a lateral angle of attack. So this is a Mars Curiosity rover wheel. This is a Pit Ranger rover.
Well, does 6.6 pounds moon weight mean the weight on the moon or down here? We're talking different gravity, so
That's on the
is it
moon.
is it heavier on Earth?
Yes.
Yes.
By about 7 times.
Oh, okay, got it.
Oh, I'm not sure. This is the moon. Yeah. Okay. 7
So
times.
1/6, yeah.
Mhm.
So this is about 40 pounds on Earth.
Okay, gotcha.
Okay. Okay, now we're going to shift to a very interesting type of thing that happens in globular clusters.
Oh boy, this is a
It's
good
a
one.
type of star called a blue straggler. The topic came up at last Tuesday's discussion on the telescope workshop. And it was not specifically about blue stragglers, but about the distribution of globular clusters. And there are odd stars in globular clusters, other places too, but much more in globular clusters where probability of hitting something else and merging is much higher than random stars in the galaxy. So there's two ways to make it. There is one on this stuff and one this way. This is where a slow coalescence model. This model, two rapidly rotating stars are in a celestial embrace, slowly merging, forming one massive star. The more massive star in this double star system cannibalizes its partner, creating a single, even more massive stars with a small thing, and either completely absorbs it or just leaves the other as a barren white dwarf. So this produces large stars that they have the combined mass, so they have more gravitational pressure, which makes the center of the star hotter, and that changes its color from, as you see here, from a reddish star to a yellowish star like our sun, and then finally to a blue star. Blue stars don't occur by themselves in globular star clusters because globular clusters contain old stars, and so they have to be small stars that have longer lifetimes. Blue stars don't have long lifetimes, so they're recently created. The other way is just for a straight-on collision. That is a slow collision or a straight-on collision, where the ejected debris becomes a single new star that's blue. And again, the extra mass acquired from the two stars together creates a hotter core. So that rotates very slowly now, but it because it's bigger and it's hotter.
Oh,
Now, this is a picture of a blue straggler in 47 Tucana. There's one right there. Can you see this, or is it washed out?
It's okay.
It's okay.
Okay.
The leftmost is very washed out, but it's
Yeah, it is
unresolved
on mine
anyway.
too. So there's one there, one there, one there, one there, and one there. Now, this is a much higher incident of them because of the cluster they're in than would be found out in free space in our galaxy.
So what you're saying is that star collisions occur, but they don't result in a big explosion like a nova. They just sort of stick together and combine.
The stars they start with are smaller, and so they don't really have enough mass to produce a real big core collapse, but they might. It might do it. Chuck, you want to say something?
Yeah, it depends on the mass of the stars merging. If you have two that merge that are beyond a certain mass, you're going to end up with a supernova explosion.
Yeah.
What
Well, they
creates
do.
the spin, Chuck?
Pardon me?
What creates the spin?
Well, they're not hitting exactly straight on, so you're going to have some angular momentum and they'll spin
Okay.
up.
Okay.
And by measuring the spin, you can look at those two different models. One is a slow rotator and one's a fast rotator, and you can tell how they formed.
Yeah.
Okay.
Well, the two direct that you pictured on the left a while ago, the direct hits, got to be rare. That's
Yeah.
almost impossible to line up exactly where they're going to hit.
These candidates, though, in a globular, well, from what I understand, the stars get kind of closer together the closer you get to the center of the globulars,
Yeah.
so the chances of the collision are better.
Yes. Yes.
But aren't the blue giants the ones that die early?
Yes, they are.
Yeah.
Yeah.
So how did they get in an old structure like that? They just formed.
So it's a matter of size.
And the big red ones are going to go off after midnight.
Yeah.
So this is a theoretical spectra for a blue straggler and a blue straggler measured in 47 Tucana. The light blue here, light green, excuse me, this is the observation, and the purple is the theoretical.
Wow.
And
Wow.
so it's a good match. It's one of the cases where our view of stellar evolution is pretty much right on.
Yeah. Yeah.
But where do they get the word straggler? What's straggling? I don't
Because
understand.
there were very few of them in the globulars.
Oh, okay.
There were a lot of those stars at the beginning of the universe, and things that form out of nebulas right now, there's a lot of them. To be in a globular cluster, they're a straggler of an earlier age. Now, this
Wow.
is a graphical representation of a what is that? A
Hertzsprung Russell diagram.
Yeah. So this is the star color. These are large stars, low temperature. These are increasing temperature. And increasing temperature stars, they burn their fuel faster. They don't live as long. And here is Betelgeuse down here. It's at 3,320 degrees C. Now, this is 300 degrees below the temperature in Kelvin. So our sun is 5,800 degrees Kelvin, or 5,500 degrees centigrade. So it's shown here as no color because it defines white for our biological eyes. But
Would it be fair to say, gentlemen, that those yellow ones on the bottom that are pictured, which are red giants, are about the same temperature as red dwarfs?
they are, but they're giants. They're just
Okay.
cool stars.
That's the only thing they have in common is the
It's the
temperature
surface temperature.
Yeah.
and therefore the color.
Everything that there is about a star, its past, its birth, its life, and its death is all determined by one parameter, the mass it starts with.
Unless you have something like a merger that happens
Yeah,
later.
and if you add more mass to it during its life, then that counts as starting out at a different time. So
It's a reset.
yeah, it's a reset. So
But-
Sirius, that's very close to us. It's actually a hot star. It's white, blue, white. It's at 10,000 degrees. Beta, I can't pronounce that one. Beta Centauri is about 25,000 degrees centigrade. The blue stars can go up to 60,000 degrees surface temperature. They burn
Beta-
pretty quick.
Is Beta part of the three stars that are our closest neighbors?
No, that's Alpha Centauri.
Oh, I see.
Beta is the other star. They're called the pointer stars because they point to the South Pole.
Well, I know it's a three-star system, and there's a
No, that's
small.
Alpha Centauri. That's a
Yeah, I
three-star
know.
system.
Okay, the whole thing is alpha. Okay,
Yeah.
interesting.
Interesting.
Which of the giants are most likely to have a supernova? Blue, or are they all subject to that?
Well, if they're a giant star, they're going to be a supernova.
Every one of them? The blue ones just do it earlier?
Well, the blue ones turn into the large red supergiants as they age.
Oh,
Yeah.
they do.
Yeah.
Oh,
So this is our candidate here after midnight.
Mm-hmm. There it
Yep.
is. Tom Totten. Tom Totten told us.
well, is it going to end up looking like the crab?
Yeah.
Something
I
like
think
it.
so.
Now, our final picture of the day, I put on there just because it's a wonderful picture. This is a picture taken by an amateur over several nights, running through November 25 to March 26, November
Good grief.
2025 to March 2026, using a Radian Raptor 61 millimeter telescope. I'm not familiar with that telescope,
No.
but there is, oh, I didn't put it in the caption. There's 115 hours of exposure time here. This is a fairly wide field of view, and the end star of the belt of Orion with the Flame Nebula next to it and the Horsehead Nebula, which is a dark nebula, Barnard 33, and quite a lot of structure in the background and the neighborhood of it. I'm very impressed by amateurs that can bring out this very, very faint detail. So this is an excellent example of image processing by an amateur astronomer.
Jerry, where's Bernard Lupin here?
Where's what?
The
Bernard's
Bernard
loop is a huge structure.
Oh, is huge.
This is just a little tiny piece of it.
Oh.
Yeah, Barnard's Loop is a giant crescent shape surrounding the entire Orion constellation, or at least on one side.
But the horse head is down at the bottom there, that little.
That's it here, the Horsehead Nebula. When you get all this detail in it, it kind of changes the tone a little bit. And this is a picture that Hubble took of the Horsehead.
Oh,
It's got a lot
God.
more structure in it.
Never seen that one.
You what?
I've never seen this one.
Oh,
You can see it's more like a unicorn or a part rhinoceros.
yeah.
looks like June. Looks like June gloom coming in over the mountains in the morning.
This is also taken in the infrared, so it doesn't correspond exactly to visible pictures of it.
Wow. Amazing.
That's just unbelievable.
Horsehead Nebula. The Horsehead itself is not, is it a shadow or is it a big glob of gas and
Well,
dust?
it's a big glob of glass. There it is right
Oh,
there.
that's-
Yeah, and it's in front of everything else you see here, except these stars are in front of it because you
okay.
wouldn't see the stars through it. There's a star that's probably in the nebula because it looks like it's illuminating parts of it.
Are the pillars nearby? The pillars
No.
of creation?
No.
They're not
That's a
anywhere near-
summertime thing.
Yeah, and that's a
Okay.
different constellation completely.
Got it.
You have to come with us up to Refugio, Ronnie.
I'll go. Let me know. I have no other life.
That's
Well,
Friday.
I think you dazzled us again. Probably think of some questions later, but we'll bring them up next week because we're going
Write
to
them down and ask them next week.
All right, listen, let's do this again, guys. I enjoy it. Let the press come up with some new talking points, and we'll be here for program number 276 next Monday morning at 11. Our potluck's a week later, June 12th, right?
Mhm.
Followed by our star party on the 13th. So how do we say goodnight, Chuck?
Asta Nebula.
Hasta Nebula, everybody.